and that's fine as well. But it's just like the homework, except for you have to do that domain part. But I want to at least see if you can do the factoring part on 1 and 2. So if you want to keep going all the way, you can. But at least for 1 and 2, I want you to do the factoring. The top is factored for number 1. That's done. The bottom piece needs to be factored for number 1. Same thing for 2. The top piece is factored, but the bottom is not. So we have to factor it. I want to walk around, kind of see where you're at, but take a second and see if you could at least factor the top and bottom of these two things. If you remember, if you need to go back in your notes, that's why you have them. Go back in your notes and kind of see, what we did for problems that look like this. We have x squared minus 1. There's only 2 terms here. Probably have to do that square root method. Number 2 has 3 terms in the bottom. That means what multiplies to add. So kind of getting used to the methods. 1 has the 2 terms, perfect squares, so we do the square roots. Number 2, there are 1, 2, 3 terms on the bottom, so we must do that what multiplies to add. Kind of giving you some hints as you're going here. Okay, kind of skimming around, it seems that we're kind of like either getting it or you're kind of just stuck. And I want to make sure that everyone's getting it. So if you are getting it and you're almost at the end, just ignore me. But if you are kind of stumped, then pay attention here. So the bottom piece, there are 2 terms. Whenever you have 2 terms with a minus sign in between, always check if they're perfect squares. In this situation, they are. So what is the square root of x squared? And the square root of 1? So I would write this as x plus 1 and x minus 1. Okay, that one's pretty straightforward. That should be your favorite one. Usually that is the favorite amongst all students, is that difference of 2 squares. Now the excluded values is what makes the denominator equal to 0. So I have this piece in green and I have this piece in blue. So in green, what is my excluded value? What can't x be? -1. Very good. Okay, when you set it equal to 0 and solve, it's always just the opposite sign if there's nothing in front of that x like there is here. In blue, okay, what makes that one equal to 0? +1. Now I asked you for the domain. Now that's going back to Tuesday, since we had a snow day on Monday. And we talked about using these excluded values from left to right on the number line to help us with our domain. What do we always start with for our domain? Good, negative infinity. Which one is smaller, -1 or 1? -1. So I go from negative infinity to -1. Wherever I stop is now where I start. That's why I'm starting back up at -1. Then I'm going to go to my other excluded value, which is 1. And then wherever I stop is where I start. So from 1 to positive infinity. And we will look more into this domain piece today because we're talking about the graphs more today than the past. Okay, the reason why we're warming up with this is because we're going to go into more detail with that domain. So you can kind of visually see it instead of just memorizing it. Okay, now let's talk about this other one. Here, on the top, there's nothing to factor. So we're just going to rewrite it like I did in black. But in pink here, I did say that if there's 3 terms, you have to use that MA table. What multiplies to add. So what multiplies to what number?
-6.
Good, and adds to 1. Good. A lot of people are like, okay, well, what number is in front of here? It's technically a 1. Well, there's a couple of things that can get me there. We have 1 and 6 and 3 and 2 are the only 2 things that I can use. Which one do you think we're going to use?
2 and 3.
2 and 3, very good. Okay, so 2 and 3, I would need, which one needs to be positive?
The 3.
The 3, because we have that adding has to be positive, so our bigger number is positive in this case. So then we would just write it with those two numbers. I'll review. X minus 2 and x plus 3. Everything that we just did for the warm-up, sorry, it's delaying here, is stuff you've already done all semester. And I know factoring was not easy for you guys and for a lot of people. But it's one of those topics that's not going away. Next semester, you won't have to worry about it too much. But this semester, you only got a little bit left. So really push yourself to master factoring because your semester exam has a lot of it on it. Okay, so push yourself to be successful in factoring, especially if you're going into 098 or if you're going to JJC. You're going to need to know how to factor. Okay, especially ones like that. Those are quote unquote the easier ones. Okay, excluded values. How many do I have here? 2. I have one here in blue and I have one here in green. The blue one, what makes that one equal to 0? 2, because 2 minus 2 is 0. That's why it's 2. What about the green one? Okay, that's supposed to be green. X cannot be negative 3. Can you tell me which one of those, the 2 or the negative 3, which one's a whole? The 2, because watch. Now you don't have to write this in, but I just want you guys to understand, especially if you were not here. If you can cancel like I am doing right now, this 2 creates the whole. If you cancel, you're removing it from the problem, which means that you are canceling it and creating a whole. Okay, which one's going to come first in my domain, 2 or negative 3? Good, because it is the smaller one. So I have negative infinity to negative 3. Negative 3 to where?
2.
Good. And then 2 to where?
Infinity.
There we go. Okay, that's just kind of review from the day 1. So if you were not here on Tuesday, that's what we learned, those 2 things. Yesterday, we just kind of practiced factoring. So that's really everything we learned. Now we're going to bring it all together and talk about like more in detail what's going on in these graphs. Okay, so we got Olaf over here telling us to recall some information because this is stuff you have learned this week. A discontinuity, think D denominator. Discontinuity denominator is what makes the value on the bottom equal to 0, which is basically our excluded values. Our excluded values, they're called discontinuities in math. Is any value that is an interruption of the domain. And that's kind of why if you look here above in our warm-up, we had this like you were stopping at those discontinuities. We were stopping at 2. We were stopping at negative 3 in this second problem on the warm-up. And that's why it's going to be interrupting my domain. It's like stopping it. Okay? And that's how do we do that? We find the zeros of the denominator. Okay, that's what we were doing. So it's kind of just like a recap. We call removable discontinuities wholes, which we just practiced. We crossed them out. And infinite discontinuities vertical asymptotes. So for example, on the warm-up, this piece, this negative 3 would technically be a vertical asymptote because it doesn't cancel with anything. Okay, there is no x plus 3 on the top. And that's why we call it a vertical asymptote. Okay, so let's all review. Now let's kind of talk about more specifically what it means to be a whole. We've already seen it, and we have done some things with it, but more specifically, if there is a common factor on top and bottom and it cancels, that's what creates a whole. So we kind of provided this definition for you guys. So if you ever need to go back, like what is a whole? They're asking me for a whole in my homework on the review and I don't remember, go back and look at what I wrote here. Okay, now we're used to just establishing what the x value of the whole is. We're going to figure out what the y value is so we can graph it. That's the only new piece today. We're going to just figure out that y value. But I'm going to put a little star here and put cancels because what cancels is what makes the whole. And I say it so many times that you're going to be sleeping and dreaming about wholes canceling. Okay, so when we look at the ones here, if you can see, most of them are all factored for us, which is kind of nice. We don't like to factor, so it's all done for us. Does A have a whole?
No.
No, so that one doesn't. I'm not even going to write it. The question is asking which ones do have a whole. A doesn't. Nothing cancels here. It does not have a whole. Let's look at B. Do things cancel on B?
Yeah.
They both do. The x plus 2 cancels and the x plus 1 cancels. So here in purple, what makes x plus 2 equal to 0? What's the excluded value? What can't x be? Negative 2. So my whole is at negative 2 something. Okay, now let's talk about this other whole piece, which is going to be the x plus 1s. Okay, what makes x plus 1 equal to 0? Negative 1. So we actually on this graph have two holes. One is located at the x value of negative 2, and the other one's located at x equals negative 1. Okay, and we'll talk again more about that, but we're just kind of practicing. Look at the next one. Does C have a hole? Yeah, it does. Okay, C has a hole as well. And where is that hole located? At what x value? Very good. Are you seeing that? Does that kind of make sense? Are you starting to see that, like, that's creating the hole? It's canceling. Okay? This next one, it's not factored yet, but we're good at these type of factoring ones. When you have two things on top here, you can take the square root. What's the square root of x? And what's the square root of 2? Oh, I just gave it to you. The square root of 4 is 2, so I have x plus 2, and I have x minus 2. And look at that. It's all factored for us. Oops. So I'm just going to rewrite it out for myself. Why is it so slow? So weird. Okay, only one of them cancels. If you look here, the x minus 2 cancels. So where is my whole located? At what x value? 2. It's always the opposite. Now the other one doesn't cancel because one's a positive and one's a negative, so be careful with that. Okay, so D had one as well. So the only one that didn't have a hole was A. Now what is this going to be then if it's not a hole? There we go, a vertical asymptote. You're starting to get it. Okay, every day you're going to get better. This stuff is completely new to you. There's no way I'm going to expect you to just be geniuses right now. Okay, you're going to get it eventually. Okay, now let's just talk about it more in depth. We already did this. If you look above, A is B that we just did, and then B is C that we just did. So we really don't have to do much work, but I'm going to show you how to find the y values. Okay, so it says, identify the simplified function, then determine the exact coordinates of the whole. So when we simplify, if you take a look, what we did above is we crossed these two things out, right? We'll take a look. In yellow, x minus 3 is the only thing that's left. That's what we did yesterday. So if you were gone yesterday, that was the only new thing we learned. That's right there. This part, the whole, is where you're going to be learning something new today. Okay, we already established up here, if you take a look, we had a hole at 2 places on this one. Oh my God, come on. Stop lagging on me here. Okay, so we had 2 holes. One was at -1 and one was at -2. We've already talked about this, so I'm just going to rewrite it. Okay, we did that above. Okay, we knew that from above. We kind of already talked about it. Now I'm going to show you how to find the y values. It's actually pretty easy. You just kind of have to know what's going on. The reason why we find the simplified version, and that's why we practiced it yesterday, is because you have to plug it back in. Okay, so to find the y value, you have to plug the -1 back in. So here we go. I'm going to plug in -1 here in red into whatever is left over. So I have -1s going in for x minus 3. What do you get? What's -1 minus 3? -4. So now you found your y value. So then you go on the graph and you can actually plot it now. Because you can't just plot -1. But you can plot whole at -1, comma, -4. Okay, so on the graph now you can actually go there and actually figure that out. We're going to do it one more time to practice because if you look, -1 is not the only one. We also have -2. So same thing in red. If you notice, I'm just changing it to a -2 instead. So I'm going to change this to a -2 because I'm plugging that in. So what is -2 minus 3? Very good. So I have a whole, and it is at -2, comma, -5. Okay? You have questions on that? You got a calculator, guys. You can just like put that in. But that's why yesterday we spent a whole day on practicing how to just get this part, the simplified part. Okay? So hopefully yesterday kind of helped you prepare to get ready for this. Well, obviously we're not factoring yet, but let's look at B. We already established B that this part cancels because B is just like C that we just did above. So the only thing that's left is 2x minus 3. The x plus 1's gone. Okay, so here in yellow, that's all that was left. Everything else went away. So the hole that we talked about earlier is going to be at -1. Okay, we did that above, so we don't have to do the work again. So at -1 is where my hole is going to be. Oop, where my hole is going to be. So now all we have to do is find out what the y value is. So let's plug it in. I'm plugging in that -1 wherever I see an x. Okay, so there's an x right there. And I'm going to take my red so you can see it and put that -1 in there. You see how I just put a -1 where I see the x's? This really just means that you're plugging in -1. That's what this piece means. So if you put that in your calculator, or if you do it in your head, you get -2 minus 3. What is that? -5. So your hole is going to be at -1, comma, -5, and we're done. Because your ordered pair, your x value you established was at -1, and your y value you plugged it in, and you got -5. So there's lots of like basic algebra and getting used to the things that we're doing here. That's really the only thing you're learning new today, and then we're just going to graph it. So everything else is going to now be review of the past couple days, kind of putting it all together. It's building one big problem, and you'll see that more next week. Okay, tomorrow is going to be like a review day for you guys. We're going to do some delta math so that you can keep practicing. Because I figured if we moved on again tomorrow, you'd be like, okay, that's just too much in 1 week. So we kind of adjusted. If you look at your calendar in the beginning of the notes, we were supposed to move on, but we thought, okay, let's make them review. And then if you weren't here, which a couple people were not, you're able to watch the videos that day or do what you need to do. Okay. All right, let's take a look at here. What is a vertical asymptote? We've already talked about it, but now we're going to really get into detail about it. It's an infinite discontinuity, which really just means you have like a line. And I'm going to put a little star here. It's going to be a line. X equals something. And it does not cancel out. It's represented with an equation. So if we look at the example in the little box here, what makes x equal to 0 here on the bottom? What can't x be? What's the discontinuity? What? X equals 3. Very good. So I'm going to put that in. That's your vertical asymptote. It's that easy. The whole was a little bit harder. You had to do some more work. The vertical asymptote is just x equals 3. I know that we're used to putting x cannot be 3. That's the excluded values. When you say x equals 3, that's telling you, remember that dotted line I was showing you guys and I was highlighting it the past couple days? We're going to see it more in a second here. But that's a line, okay? X equals 3 is that line. Okay, so now let's talk about it. Here's the graph, kind of show you an example. We're only going to do one on this page, and we're going to do the both of them on the other page to kind of save some time, to give you some time for homework. Okay, number 1's a little bit harder than number 2, so I'm obviously going to choose number 1 to make sure that you guys are getting the best that you can here. You're going to have to factor both the top and bottom, so look at all these pieces. So if you notice here, I kind of want to explain what I meant by taking it day by day. For letter A and B, you guys learned this on day 1. Okay, then you are learning this on today, and you're learning this today, and you learned this on day 1. The factored form actually is going to help you, and it was yesterday as well when we learned about the simplified form. Okay, so let's take a look here. Let's factor the top. What does the top factor into? X plus something and x minus something. What is it?
X plus 3 and x minus.
Good, because the square root is 3 and the square root's x. So it's x plus 3 and x minus 3. Pretty simple for that one. I feel like you guys like that one the most. However, the bottom has 1, 2, 3, if you count them. 1, 2, 3 terms. So I have to go to the side over here and say what multiplies to -12, but also adds to -1. Now I'm going to show you, again, if you get stuck with those numbers, some of you in like 5 seconds will be able to tell me what that is. And that's all you. You don't even have to come over here and make the table if that's you. If you know that in your head, just do it. Okay, but if you don't, please make the table. So I have 1 and 12, that's not going to work. 12 divided by 2 gets me 6, that's still not going to get me -1. 3. 12 divided by 3 gets 4. Can I get -1 from 3 and 4? Which one would have to be negative, the 3 or the 4? Very good. +3 and a -4. The reason why I want a -4 is because my adding part is a -1. So the bigger number must be negative. Okay, so now we have that here. X plus 3, x minus 4. Which was the factored form. I probably should have just came down here and rewrote it. So I have, let me go back up. X plus 3, x minus 3. I'm just rewriting it. And then we got x minus 4, x plus 3. Was that it? Yeah, that's it. It's okay if you swapped it. I accidentally swapped it, but it doesn't really matter. Now, just because there's all this stuff here doesn't mean you can't do it. Okay, you just got to take it piece by piece. On the homework, you only have 3 questions because I want you to take your time. Okay, identify the discontinuities. Think discontinuity starts with a D, and you want to look at the denominator. Okay, so the 2 things that make, the bottom equal to 0. What about in yellow? What can't x be? 4. And what about in blue? What can't x be? Very good. Does anyone have questions on why those are the answers for the discontinuities? You set them equal to 0 if you forget. If you're like, I don't know where that came from, I'm missing a step, you can do x minus 4 equals 0, x plus 3 equals 0, and that will help you with your answers there. If that's something you need that step, please write it in. Don't be ashamed if you have to write that step. Okay, now here's the cool part. We're going to use what we just did to figure out which one's a whole and which one's an asymptote. They can be both a whole and they both can be an asymptote, which depends on the problem. One of them is a whole. Which one's the whole? Good. This piece right here creates the whole. This is a whole in your graph. So I'm going to write that -3, because that's what it goes with, down here. And get myself ready, because we have to find the y. Now, the vertical asymptote is what's left over. If you look, this one does not cancel, the yellow piece. That's why x equals 4 is the vertical asymptote. So that's my favorite one, is a vertical asymptote, because you just copy it down. Okay? So what you're doing in this part is you're taking these two and deciding which one they go to. Because you're like listing all of them, and then you're like, okay, I'm going to be a little bit more specific. The 4 is an asymptote, and the -3 is a whole. Okay, so it's not like you're doing more work, you're just choosing where they belong. So now let's plug it in. Remember, you plug it into what's left over. So here we go. I'm going to plug it in. F of -3. I'm plugging into this piece right here that's left over. So I have -3 in red, plus 3, because that's part of the problem already. And then I have -3 minus 4, because again, that's part of the problem already. Do you see how I'm just taking, why is it taking so long to load? Oh my gosh. If you see here, I'm just plugging it into this piece that I circled because that's all that's left over. If you plug it in with everything, you're going to find yourself having an error on your calculator. So you can do this in your head, or you can put it in your graph in your calculator. You can choose. Take a second and see if you can type this in. Parentheses, -3 plus 3 divided by -3 minus 4. You do get 0. Let me just double check I did something right. Oh my God, did I cancel the wrong thing, guys? I did. Look. Go back in your notes. I apologize. Take a look. Do you see how I canceled the x plus 3 with the x minus 3? That was my fault. Hopefully I didn't confuse you. Okay, so I canceled the wrong thing. So please make sure, hopefully you had an eraser, this piece cancels because they're both the plus 3. So please make that adjustment. Take a second. and make that adjustment. And that's why it was coming out weird. I'm like, why is this coming out strange? Because now if I come back down here, this piece right here just changes to a -3. That's it. Everything else is the same. So go ahead and plug that in your calculator now. So I have -3 minus 3 divided by -3 minus 4. Sorry about that. Everyone makes mistakes. Make sure you just are careful with your signs. You get a weird decimal? Let me help you guys type it in. So you want to go to, so I can quit. There are two ways you can do this. I'm actually going to show you guys a really cool method with fractions so that you never have to worry about parentheses. If you press the green button, alpha, and you press y equals, do you see this little n divided by 3? Sorry, n divided by d? If you press enter, look, it makes the fraction for you. So that in the future, you would never have to worry about parentheses again. So you guys had 3... Did we do, hold on, pause. Yeah, we got that right. Cool. Here we go. Sorry, my brain. Okay, -3 minus 3. So -3 minus 3 all over -3 minus 4. -3 minus 4. 6 over 7. See, isn't that kind of nice when you do that? If you got a weird decimal, I would accept decimal answers. You can use decimal answers. It's okay. So we're going to use 6 over 7 here. Go back. 6 over 7. Questions on that? Sure? Okay, and now we're just going to talk about the domain, which is our warm-up. Our warm-up. Or you can look at the graph, guys. If you take a look here from left to right, I always go from -infinity and I stop wherever I see like something wrong with the graph. If you see here, -infinity, I stop at -3. Like there's something going on there. And then I also stop at 4. So there like is a visual for you guys on why the domain stops at 2 places. So I have -infinity and I always end up positive here. So here we go. -infinity and I stopped at -3. I start back at -3, and where am I going to go? Where's the other x value that I'm going to talk about here? 4, very good. And then 4 to infinity. And I'm going to draw an arrow here because the only thing that can help you besides the graph is this piece right here will help you figure out your domain. If you notice here, the -3 is involved and the 4 is involved. That's why we list those. It's crazy how it all works. Think about the D. Discontinuity, denominator, domain. They're all D's. Okay? Discontinuity, denominator, and domain. All of them are D's, and they're all going to help you out to, or help each other out to do this problem. We're not going to do the next one. We're going to skip so that we can practice graphing them ourselves. Okay? So we want to skip to the next page, please. And if you look, number 1 is all factored for you guys. I wanted to give you a break on the factoring part. So that's awesome. All factored for you. So the factored form, I'm just going to like draw an arrow because we already did it. It's done. There's nothing to factor. A good way to kind of see if something's factored, look and see if there's like x squared. If there's an x squared there, I would definitely check and see if you can factor something out. Identify the discontinuity, which means denominator. Discontinuity, denominator. What makes the denominator piece right here equal to 0? What? Good, -4. Do we have questions on that? If you're getting stuck with that because maybe you weren't here, set it equal to 0 and we subtract 4. That's how we got that. Okay, that one's easy. Now let's talk about this. There's only one. It can either be a whole or it can be an asymptote. It can't be both. So, is this -4 going to be a whole or an asymptote? A whole, because look, in pink, it cancels, which creates a whole. So guess what? There is no vertical asymptote because there's nothing left on the bottom. There's nothing. So there's only going to be this whole, and it's going to be at -4 something. We don't know what it is yet. And this one's an easy one because x minus 2 here in blue is the only piece that's left. Okay, so let's plug it in. F of negative 4 is going to be negative 4 minus 2. Yep, minus 2. So in pink here, I'm plugging in that negative 4 where I see the x. What is negative 4 minus 2? Very good, negative 6. And that's our other part of our coordinate. So when we graph on the graphing calculator, we would have to put a little circle there at negative 4, negative 6, okay? The domain. Again, the discontinuity has a d in it, so does domain, so does denominator. Okay, so the only piece I have to talk about is negative 4. Where do I always start? Negative, and I go to where?
Negative 6.
Careful.
4.
The negative 4. It's always the discontinuity part. What can't x be? Always. What can't x be? I kind of circled it and drew it down there. Okay, and then it goes from negative 4 to infinity. If there are 2 discontinuities, it'll be a lot longer. Sometimes you might have 3 and it'll be even longer of a domain. But whenever there's only 1, it's pretty straightforward. So let's get out our graphing calculators and just practice graphing this together. I really recommend that you do this with me and not just watch, because you want to make sure that you can type these in. Okay, and then we're going to be pretty much done here. So I'm going to go off to the side so you can see both my screens. Okay, I'm going to go to y equals like I always do. Clear it out if there's anything in there. And if you need a calculator, they're over here now. I changed them because they were... we were missing one last period until we found it. So, okay, we got to keep them close to us now. All right, so let's type in our original problem here. Let's take a look. I'm going to show you again how to do that fraction. Otherwise, you're going to be dealing with a lot of parentheses here. So press that green alpha button and then y equals. And press that 1 or press enter, doesn't matter. And there you go, a beautiful fraction. You don't have to mess with anything. And I'm going to maybe write on my notes here for you guys. For your calculator, press alpha y equals for a fraction. That way, if you're at home or you're doing your homework later, you can figure out, how to get that fraction in there. Did anyone not get the fraction on their calculator? Okay, it's just typing it as we see it. Parentheses, x minus 2, close it up. Parentheses, x plus 4. You want to put everything in. You don't want to leave anything out. I know we canceled it, but when we're graphing it, we got to keep it all in. And then we have x plus 4. Any questions on that part? And then let's just take a look at our graph. Kind of see what's going on here. It's a line. It kind of makes sense that it's a line because think about it. X minus 2, the blue part that we highlighted, is linear. It doesn't have a square, it isn't cubic or anything, it's linear. So it should be a line. Now I just want to show you something, kind of a trick for you guys. If you press second table, take a look at negative 4. You don't have to do it, you can just kind of look off of mine. Do you see how negative 4 says error? That's because it's undefined. It doesn't work. It doesn't exist. And that's why I keep telling you guys that on your calculator it will say that, and it does. Negative 4 says error on your table if you scroll up, if you press like the up button to get there. Okay, if it doesn't, then your graph is wrong probably. Does it say it? You're good. Okay, so now let's go back and let's graph this out. I'm going to kind of have this as a reference off to the side here. All right, so the only things that you need to draw in are your whole and your asymptotes. So if my computer will work for me here, maybe not. Here we go, here we go, here we go. Okay, the only things that you want to draw in are your wholes and your asymptotes. So right away, I'm going to go to negative 4, down 6. 1, 2, 3, 4, 5, 6. I'm going to draw this big hole. So I know that there's a hole in my graph. Then you guys just can just like sketch it. Look off of your graph on your calculator and be like, okay, it looks like it's going like this and like this. Done. Okay, if you want to be super accurate with it, by all means, please do so. I would be more than happy to have accurate graphs. But I'm just saying, I really don't care. I just want you to sketch it, but you need to identify the hole is there. Okay? Let's go to this next one, and I'm going to like kind of breeze by the factoring for you. I mean, it's an easy factoring one, but you're going to have 3x on top. What can I factor out of the bottom? What goes into both of these? A 1 and an x. Someone said it. So an x comes out, and you're left with x squared minus 4. Again, I'm going to breeze by this one only because I want to make sure you have time for your homework, and you guys are pretty good at this type of problem. Now, we have to do it one more time. I won't give you one like this on the test, but you would have to do it again. That square root method, x and 2 here. So I would have the x on the outside, x minus 2, x plus 2. So like I said, I'm just giving you the factoring part. I'm not going to ask you one like that in the homework. We have to do 2 steps of factoring. Make a note for myself for next year to kind of take that x out. But now look, how many x's are on the bottom?
3.
There should be 3 discontinuities then. If there are 3 x's on the bottom, you should have 3 discontinuities. Here's one in yellow, here's one in blue, and here's one in green. So the yellow one, when you set it equal to 0, it's just 0. X can't be 0. What about the blue one? What can't x be? It's always the opposite sign. 2. What about green? What can't x be? Very good. I'm going to stop there and ask, does anyone have questions on where we got all 3 of those? Because I will explain it again. Okay, now, some of them are asymptotes, some of them are holes. Let's see if you can kind of identify which one's the hole. It's kind of a toughie. Which one's the hole? The 0, the 2, or the negative 2? So is there an x plus or an x minus 2 on the top? No. So we know that one for sure is a vertical asymptote. So we have x equals 2 here. Does the x plus 2 cancel with an x plus 2 on top? No. So that also is a vertical asymptote. That's kind of how you establish it. Does it cancel with something on the top? This 0 part. Does this yellow piece cancel with something on top? It does. Okay, in red here. This cancels with the x, not the 3. It just cancels with the x piece right there. So we have a hole at 0 something. We got to figure out the y. Okay, here we go. Kind of zooming by here. We're going to plug it back in to what's left over. So I have 3 divided by, in green, 0 minus 2. And then we have 0 plus 2. Where am I getting that from? Right here, the factored form. 3 is left on top, and these blue and this green piece is left on the bottom, so we have to plug it in. So in your calculator, let's plug it in. I'll help you practice putting it in. Second, quit. Press the alpha, y equals, and boom, there's your fraction. I get 3, press down, and then I have 0 minus 2, parentheses, 0 plus 2. If you take a look, we get negative 3 over 4. So negative 3 over 4. I just want to make sure we get this down on the notes here. Okay, I'm not even going to do the domain because you guys get that part. I want to make sure we get the graph down. I need you guys to put stars next to the hole and the asymptote because those are the things that you have to graph. And I'm going to show you how to do that right now. I know we're kind of running out of time here. I apologize, it's a longer lesson. Okay, so x equals 2 and x equals negative 2 need to be graphed. So here's how I'm going to graph them. The vertical asymptote at negative 2, I'm going to draw dotted lines in there. Because what you just did, you've created this like wall where the graph cannot touch it. You've now created a wall on your graph. The other one was at 2, so I'm going to draw another one. The other one that we starred was the hole, and that's at 0, negative 3 over 4. So in purple here, that's like maybe right here. Okay, just draw a big circle there because that's where your hole's at. That's the only important things I care about. Now you can just go to your calculator and graph it. Because we're running out of time, I'm just going to graph it for you. so that you guys can start your homework. If you were to go to y equals and type this in, which you guys are all good at now, it would look something like this in purple, and it would look something like this. It's scary. It looks weird. Like we've never seen graphs that looked like this before. I get that. But really the only part that I'm concerned about is that you have these dotted lines representing that the graph can't touch it, and the zero, this little circle part here. So the only new part that we learned today was F, which is this graphing part, and the only new part also was D here. The other stuff you've done before, so that's why we're taking every day to kind of build off of each other. Tomorrow, all day will be review, because I don't want to move on. I want you to master